Should we start? Okay. Hello everyone. My name is Anuj Kumar. I am working as a Prime Minister Research Fellow at IIT Roorkee, and I am here to discuss the assignment 2 for this course Trace and Ultra Trace Analysis of Metals using Atomic Absorption Spectrometry, which is instructed by Professor J.R. Mudkavi. Okay, so I will be discussing similar to assignment one. I will be discussing some optional questions, and after that, I will be discussing some numerical problems. Okay, so this is the question one for assignment two. Uh, you are asked that the magnetic quantum number varies from. These are four options given here. That is, one is 0 to L, 0 to 12 plus 1 minus L to L, and none of these. I'll be waiting for 2 to 3 minutes, and after that I'll explain. Okay, you can also type the answer in the chat box. L is basically the azimuthal quantum number. Okay, the answer is C. Right, right. The answer is C. Okay, so this is the definition of magnetic quantum numbers. It basically specifies the orientation in a space of an orbital of a given energy. That is the principal quantum number, and L tells about the shape. Okay, you already know about L is equal to 0, 1, 2, 3, corresponding to S, P, D, and F orbitals. Okay, so this number divides the subcell into individual orbitals, which holds the electrons. Okay, so there are 2L plus 1 orbitals in each subshell. Thus, the S subshell has only one orbital, like this, and P has 3, D has 5, and F has 7. Okay, already that if you have to make the S orbital, you make only one subcell, and for P orbital, you make 3. So, this is the magnetic quantum number. Okay, so it tells about the orientations. So these are some typical orientations you can see here. So 2L plus 1 is the, if you have to calculate how much orbitals are there in each subcell, you can use the following formula, that is 2L plus 1. Okay, 12 plus 1. If for P I will be calculating, it will be 2 into 1 plus 1 is equal to 3. Okay, so these three subcell will be there, and it will have the magnetic quantum number, that is minus 1, 0, and plus 1. Okay, so the value of magnetic quantum number lies from minus L to plus L. Okay, so this is the another questions, that is the question is picked up from the origin of atomic absorption spectroscopy. That is, the dark lines in the solar spectrum are due to, you are given four options, that is non-emission of certain wavelengths, absorption by atomic vapors of some elements, scattering by particles, and fourth one is none of these. So I will be showing the dark lines pattern. in the next slide. But before that, you have to identify the correct option for this question. Okay. So these patterns you can see here. There are some dark lines corresponding to different elements, that is oxygen, sodium, helium, iron, and calcium, etc. For a specific wavelength, you can observe these dark lines. So what is the phenomena? If there is a source of continuous spectrum like solar, uh, you can consider solar spectrum. If a cloud of gas if a cloud of gas in between the path of these radiations, so these specific wavelengths are absorbed by the vapors of these elements. So there you cannot see any bright spectrum. You can observe only the dark lines. Okay, so the correct option will be the absorption by atomic vapor of some elements. This is very deeply discussed in NPTEL lectures also. So the next question is also a very basic question, that is a plane polarized electromagnetic wave. You have to identify the property of plane polarized electromagnetic wave. Uh, First is it exhibits has vibration only in one plane. It has vibrations in all directions. It has vibrations between two poles. It exhibits no vibrations. Okay, if you see this figure that defines the polarization of light waves. Okay, so this is unpolarized light here. Okay, if there is one polarized or polarizer, so it will convert into a single plane polarized light. Okay, like light, you can see here, this is the unpolarized light. If I place a polarizer here, so it will allow to pass only vibrations that is parallel to this plane. Okay, so that will be called the plane polarized light. So it will be having vibration in one plane only. So the first one will be the right answer. Okay, if you have any query, you can type in the chat box, or you can ask by unmuting yourself. So the next question is the energy of photons in electromagnetic radiation. This is a very interesting question. Uh, you have to basically tell me the relation between the intensity of light and energy of photons. Okay, so you are given four options here: independent of intensity of light, proportional to intensity of light, or inversely proportional to light. None of these. Sorry, how you can say that photons is proportional to intensity of light, energy of photons? Can you please explain it? Sometimes people are confused that if the light is brighter, then intensity will be high, right? So if you see the expression of energy is equal to h nu, right? And you can further expand it like this. Okay. So in this expression there is no intensity. So it is independent of intensity of light. Okay. Hmm. I think your voice is very low. I cannot correctly listen to you. Yes, yes, please. Yeah. Yes, yes. There can be change. Okay. So you are only you can. I think you can see the lectures by Professor Mudkavi sir. He has clearly explained that. Okay, so you can see like you are saying that if I'm seeing the red light, okay, I can see the light has very high intensity, right? Right, right. But there is no fundamental relation between intensity and energy of photons. Okay, understood, no? Okay. So the next question: in normal dispersion for a given media, okay, you studied about two types of dispersion. First is normal dispersion, and second one is the anomalous dispersion. Okay, so this question is about normal dispersion. There are four questions, four options. That is, first is the refractive index increases with increasing frequency. It decreases. It remains constant, or refractive index has no relation to frequency. Yes, it is. So if I'm saying that refractive index decreases with increasing frequency, that will be anomalous dispersion. Okay, in normal dispersion, you generally observe the refractive index increases with only increasing the frequency. Okay, so here is the phenomena. Dispersion is a complex phenomena. Okay, it basically shows two reasons. Here you can see there is normal dispersion. Here you can see there is a rise in refractive index with increasing frequency. Okay, or and if there is this region, you can see there is a sharp decrease in the refractive index. So this is called the anomalous dispersion. Okay, so these are generally two terms related to dispersion. Okay, and the next question is about Pauli's exclusion principle. You have to identify. First is two electrons cannot have the same quantum number. Second one is two electrons of same atom have the same quantum numbers. And third is no two electrons within any atom can have the same set of quantum numbers. Or the last one is the electrons are interchangeable in any element. Just carefully read the statement and identify which will be the right answer for exclusion principle given by Pauli. I will be briefly explaining it. See, Yeah, C is the right one. uh, okay, so on the basis of this principle, you have to identify the right option for this. So, which electron configuration represents a violation of the Pauli exclusion principle? You are given these four electronic configurations. You have to identify which violates the this principle. Okay, one S, and there can be one another. Okay, C. Okay, I think C. Okay, let me write this. This is 2p. This one. Okay. So if I talk about the quantum numbers for this electron, okay, so n will be 2, right? And L will be 1, okay? And magnetic quantum number will be -1, 0, and +1, okay? Are you listening? And okay, third one. Oh, sorry, fourth one, right, right. Yes. So you were saying about this one, right? Third one. Okay. So let me explain it also. So if I'm talk about 2s, okay, for the principal quantum number will be 2, right? And L equal to 0, right? And M will be also 0, right? But the spin value will be plus half for one electron and minus half for another electron. So this quantum number will be different. So this option doesn't violate the Pauli exclusion principle. Yes. A, if I see n will be 1, L will be 0, M will be 0, and S will be also same for both the electrons. So this first option will violate the Pauli exclusion principle, right? Okay. Okay, I have already explained it. This one. Okay. So magnetic quantum number basically tells about the orientation in the space of an orbital. Like if you are having, uh, let me explain to you. If you having d orbitals, right? This five subcell is there. Okay. So you will be having magnetic quantum numbers plus one, plus two, plus one, zero, minus one, and minus two. Okay. Right. So if I explain you, there is five orbitals. One is dx square minus y square, another is dz square, one is dxy, dyz, and dzx. Okay, so what the magnetic quantum number tells us, this dx square minus y square, if I am considering is x axis and I am considering it as a y axis, okay, so this orbital will lie on the axis plus y and minus y side, and also on the x positive and x negative, right? Similarly, this one, it will be like this, dz, positive and negative, right? And if I am talking about dxy, okay, so here in between the axis, it will lie, right? Similarly dy by dx. So magnetic quantum numbers basically gives us the information of orientation. Okay, so n tells us the quantum number, principal quantum number. Okay, the number of cells. Okay, and l tells us about the shape, right? But m tells about the orientation in a space, how the electrons, how the orbitals are oriented in the space, right? Okay, so okay, so the next question is related to prism. In you have read about litro mounting and cornu type mounting. Okay, so you have to identify in litro mounting dispersed radiation is collected on the other side, or it not scattered or collected on the same side. Are you? Yes, right. So if you see here, it is a 60-degree prism, okay, and one is 30 degree, okay. So you can see in cornu mounting, the dispersed radiation is collected across the prism, right? And in litro mounting, it is collected on the same side. Let's see. If any radiation coming from here, it refracted. Okay, so here is the mirrored surface. So what it will do, it will reflect back to that ray. So the radiation is incident on this surface and also collected on this surface, right? So this type of mounting is called litro mounting. Uh, so refraction takes place twice on the same side. Okay, if you are having if you want to save the space for designing of any instrument, you can use this 30-degree prism, right? And this one is a simple phenomena, that is a prism dispersion of light, right? So another basic question, that is you have to tell about the Planck constant value in joules second. Yes, yes, that will be the. So you have to remember these values, Planck constant, and see. Uh, you will frequently use these values while solving the numericals. Okay. So the first numerical of this assignment two. Okay. So energy expression for any electron is given here. Z is the atomic number, N is the principal quantum number, right? So wavelength of light required to excite an electron in hydrogen from level 1 to level 2 will be, okay. What you have to determine, that is the delta value, okay. Just try to solve. I will be waiting only for 5 minutes. If you are getting, kindly tell me, otherwise I will proceed for the solution. Z is 1 for hydrogen. Z will be 1 for hydrogen atom. Are you getting the solution? So let me give you a hint. So if I talk about the delta E, that will be E2 minus E1. Okay, and you can expand it at C by lambda E2 minus E. And E2 value you can get from here, and E1 value you can also get from here. Put put Z equal to 1. Put Z equal to 1 here for hydrogen. Right. Have you got it? Okay, let me solve it. Okay, if I'm writing here the expression for energy, that is E is equal to minus 2.178 into 10 raised to minus 18 z square by n square. Okay, so E2 will be minus 2.178 10 raised to minus 18 1 by 4, and E1 will be minus 2.178 10 raised to power minus 18 and 1. Okay, so Hc by lambda equal to, if I'm taking it a common value, so 1 by 4 and minus 1, right? Okay, and put here the value of this 3 into 10 raised to power 8. Okay, and solve it. So you will be getting the first one option. Okay. Hmm. So another one interesting question, that is, in any experiment or in any heat treatment of muscular pain, it involves the radiation of wavelength of about 900 nanometer. So we basically need the radiation of wavelength 900 nanometer. So which spectral line of hydrogen atom will be suitable for this purpose? We have to calculate the line. Which line? There are four lines given here. First is the Parson line 5 to 3, Parson infinity to 3, Lyman infinity to 1, and Balmer infinity to 2. And the standard values are also given here. First is the Rydberg constant, that is 1 into 10 raised to 5 centimeter inverse, Planck constant, and velocity of light. What you have to do first, you have to apply the this formula. Okay, and check for all the four options. After putting n1 and n2 value, you have to convert this centimeter inverse to nanometer. Let me tell you how you have to convert that unit. If I'm saying, let's say this value is k, okay, and 1 upon k, so RH by k, and if you have to calculate the lambda, it will be k by RH, right? So the lambda is equal to k by RH value is given here, 1 into 10 to 5 centimeter inverse, right? If I'm take it here, that will be k into centimeter divided by 1 into 10 raised to 5. Okay, if I write 1 meter here and divide by 100 centimeter, that will be the same thing. And if I also multiply further 10 raised to power 9 nanometer and divide by 1 meter, okay, so centimeter will be cancelled out, meter will be cancelled out, so centimeter will be cancelled out and meter also cancel out. You will be having only this 10 raised to power 9 nanometer. So you will be getting k multiplied by 10 raised to power 2 nanometer, right? So if I will be getting this k value is 9, so the wavelength will be 900 nanometer, and I have to find the suitable radiation corresponding to this wavelength, that is 900 nanometer. Okay, so if I take this option, okay, so 1 upon n1 square will be 1 upon 9, and for infinity it will be 0. Okay, so I will be oppositing it and I will be getting this 9 value, right? So this radiation will be suitable for this purpose. Have you got it? Is it okay, Mansu? Understood. Okay. So the another simple question, that is, you have to calculate the energy of photons corresponding to this wavelength 430 nanometer in kilocalorie per mole. Okay. So just try to calculate by this formula. Simply put up, that is this. But this value will be for one photon, right? Because and the complete expression, if I talk about it, is n h nu, n is equal to 1. So whatever value you will be getting, you have to just simply multiply by Avogadro number, right? That will be your answer in joule per mole, and after that you can convert into kilocalorie per mole. Okay, nanometer you have to convert it into meter. Okay, you will getting the answer in joules, right? And after that you, yes, yes. After that will be, because this expression is for one photon. Okay, and if you have to calculate the per mole, you have to put the value of Avogadro number, that is the 6.023 into 10 raised to 23 photons per mole, right? Okay, so this was the last question for this assignment. If you have any query, you can ask me. Yes. I have talked about the presentation, and he responded that there is a option to download transcripts and videos also. I personally did not join the this course, but you can find there. If you can see in the sides, there are week-wise lectures. Okay, at the bottom, you can see here there is the option to download transcripts. Okay. If you can, okay, if you will be unable to find out, you can email me. So I am writing here my mail ID. That is Anuj underscore K at the rate pp dot iitr dot ac dot in. Okay. If you will be unable to find, I can send those lectures to you, or I can send the link. Right. What was the last date for that? Okay, you can check the last date, and before last date, you can submit it. If you miss last date, you should contact the NPTEL team, but basically they will not allow to you to submit the assignment after the end date. Okay, but you can only request them to extend that date. But as far as I know, they will not allow. Okay. But you can solve the assignment too and submit it as soon as possible. Okay, so that the deadline should not be gone. Okay. Okay, so it was nice to talk to you, Himanshu, and thanks for attending this session. I'm leaving now, right? Okay.